Hello, this is Stephen DeMarney. Today we are going to learn a bit about fuses and their usefulness for our robot circuitry and any electrical circuit in general. Now here we have a 3 amp glass fuse that I have from my hobby parts kit. Now I will describe the parts of this fuse. Now the main body of this fuse is glass, and you can see the glass there and that makes up, it's actually the whole length of the fuse. And then the second part of this fuse, or parts, are the end caps, and you can see these looks like silver end caps. And these end caps are made from nickel plated brass according to the manufacturer. And third, it's very thin, but there's a fuse element, if you can see it in the glass, that runs down the very center of the fuse. And it is joined to each end cap on the ends, so that the center of the fuse is like a conductor. And this type of fuse requires a fuse holder so that we can connect it in a circuit. And here is a plastic fuse holder with conductive spring clips. You can see conductive spring clips here to hold the fuse, and spade terminals for connecting the fuse into a circuit. So I'll just show you connecting, how to put the fuse into the fuse holder. You just take it like that, and then you have to press hard and it goes into the spring clips. Now, how does a fuse protect a circuit from overcurrent? The fuse element in series with the circuit acts like a very low value resistance and heats up a little bit with normal current flow. The resistance of this 3 amp fuse is too low to measure with my ohm meter. It looks like a good conductor of 0 ohms to my multimeter, and I'll show you right now the resistance according to the multimeter. So there we can read it's showing 0.0 ohms. Now the actual resistance of this 3 amp fuse is 0.0427 ohms, and that's according to the manufacturer's data sheet. We would need a different meter called a micro ohm meter to measure a low resistance like this. Now when there is excessive overcurrent flowing through the fuse element, it heats up and melts. When the fuse element melts, the fuses become an insulator and no more current can flow to the fault condition. When the fuse is opened, it is common to say the fuse has blown. After a fuse has blown, it must be replaced with a new fuse. The faulty component or wiring must always be located and be fixed or replaced before replacing the fuse. Fuse ratings. When we look at the fuse, we can see some markings that are embossed on the end or on the ends, in this case just on the end of the fuse cap. Now the first marking that we can read says 3A, and this stands for 3 amps. The fuse is rated for 3 amps of current. For best practice, we would use this in circuits having at the most 2.25 to 2.4 amps of continuous current, as the fuse could blow on us if we run 3 amps of current through it for more than 4 hours. The amperage rating of the fuse to use for our circuits has to be based on the ratings of the components and wiring we are trying to protect. Now the second marking, it says 250V, and that means this fuse is rated for use in circuits up to 250 volts. It is important that the fuse has a voltage rating greater than the voltage we are using in our circuit. And the next numbers that we can see, the markings are 3, 1, 2. This happens to be the manufacturer's fuse series number. This fuse is a 312 series fuse manufactured by the company called Littelfuse. We can find a data sheet and other literature online for the series 312 fuse. So I recommend fuses to be used for all our robotic and other electronic and electrical hobby circuits so that there is suitable protection from overcurrents. I will be recommending suitably rated and sized fuses to use for the projects we do in the robot parts training course. There is much more to learn about fuses, and I encourage you to study more about fuses by looking on the internet, and if the opportunity is there, learning about them at school. Be sure to watch Robot Parts Training 6, the next course, on solderless breadboards, to learn how to use the board for building and connecting electrical circuit projects.